Okay guys, in this video, I'm going to be showing you how to create both 659 index feed and 6.60 bearing. Let's start on 659. Create a sketch on the XY plane. We're going to create two rectangles. One horizontal rectangle like this and one like this. We're going to use our coincident constraint to line up our rectangle with the origin and our other rectangle with the origin. Once you have those two locked in with the origin, we can go ahead and dimension these. The first rectangle is going to be our overall dimension from left to right, which is 3.25. The bottom rectangle is going to have a width of 0.75. Now let's add our overall height. From the bottom of our second rectangle to the top of our first rectangle, this is going to be 1.56. Our bottom rectangle is going to have a height of 0.19. Once you have all of this information, go ahead and finish your sketch. We're going to extrude this by a distance of 2.5. Our next sketch we're going to put on our top face. Pay attention to how it rotated and make sure that you rotate it so you're reading the view cube from the top like so. We're going to go ahead and project our geometry of just the top rectangle and then draw some lines. I'm going to start in this bottom corner, draw a line, then from that line I'm going to angle it. Make sure that you guys don't connect it to any of the lines that pop up, and then make a vertical line that connects to the top line. Once you have that, we can go ahead and dimension things. This angle is going to be 40 degrees. This distance is going to be 0.25. And the location of this line from this right edge is 1.25. Once you have all of that information, go ahead and finish your sketch. We're going to be cutting away some of this material. So go to extrude, and we're not selecting this because this is what we want to keep. We're going to be getting rid of this. So go ahead and extrude this profile down into the part 0.75 inches. Next, let's rotate this part so we're looking at this left side face. Make a sketch here and go ahead and project our geometry. Then we are going to create a line and dimension it. This has an angle of 30 degrees and a distance, or this length, is going to be 0.94. Once you have that, finish your sketch and extrude just this shape. And we are cutting this through all. Rotate it back so we're looking at it in this isometric. So make a sketch on that top face, project your geometry, and then make a line. This triangle has an angle of 50 degrees and a distance of 1. Once you have that, go ahead and extrude this down into the part 0.19. Our last information that we need to put in is that there is a hole right here. So create a sketch on this face. And to create holes, it's super simple. All we're going to do is put a point somewhere on this face. Now we are going to dimension this. From here to the front face is a distance of 0.75, and the location from here to this line that we can't see but we're going to project it is 0.38. If we turn it, we can see that this line is this hidden edge down here. Once you have that, go ahead and finish your sketch, and we are going to use a brand new function, which is this hole button. This hole button automatically sees that that point is where we want to put our circle or our hole. This hole has some information that we need to put in. This hole is a counterbore. So we need to change this hole to just a regular simple hole, and then the seat is a counterbore. Next, we have to change all of this information to match what the original drawing says. The counterbore has a diameter of 0.75. The counterbore goes into the part 0.38, and the diameter of the hole is 0.5. So as you look at this part, you'll see that we have a larger hole and a smaller hole. These holes exist so that the bolts can sit under the actual surface of a part. Once you have this, go ahead and click OK. That completes this part, so let's go ahead and save this. So when we create a new drawing, we have to go over to this pull-down menu next to ENUS and select the metric folder. As you notice, a whole lot of options pop up. We are still creating an IPT, but we are going to be using standard IPT. Go ahead and click Create. We are going to create the first sketch on the XY plane. If you look at this part, you'll notice that there are circular features throughout. So we're going to start by creating a circle on the origin. The size of this circle is going to be 64 millimeters in diameter. We're then going to put two circles on either side of the central circle. Next, let's dimension this. Each of these circles has a radius of 17. We have to figure out the diameter. Instead of using our brains, we can use Inventor's calculator. So type in 17 times 2 and enter. And that gives us what 17 times 2 is. And that has a diameter of 34. Make both of these circles equal with each other. And now let's dimension their locations. The right circle is 48 millimeters away from the center, and the left circle is 96 millimeters away from the right circle. Next, let's line up our circles using our horizontal constraint and click on the center points of each circle. Now that everything is locked into place, we can add more features. I want you guys to draw 4 standalone lines. 4 lines that should look something like this. We are going to be using our tangent constraint to make these lines touch these circles at just one point. So I'm going to click on tangent, click on my line, and then my large circle. I'm going to click on the line again, and then the small circle. And then I'm just going to repeat that process all the way around my entire part. Remember to have if you have any difficulties with any of these lines, just delete the line and redraw it. Next, I'm going to use my trim function to trim away any of the extra lines that are hanging over where I wanted everything to be. If I look closely, I can see that this line isn't fully touching my circle, so I can hold down the Shift key, and instead of trimming, it extends my line to actually touch the other lines on my drawing. That is something that you guys should keep in your back pocket as you draw anything in the future. Go ahead and finish your sketch. Once you have this, go ahead and extrude all of your shapes, our circles, and each of the segments that we created with our lines. We're going to extrude this by 14 millimeters. Next, let's create a sketch on this top face. Project your geometry so that way we can use our center points of each of our circles and create a circle on the middle center point. This circle is just going to touch our existing circular edge. We want to use our equals constraint, click on our circle that we drew and this edge so that way we are double sure that this is equal. Go ahead and extrude this by 19. Next, we need to add some holes. So I'm going to turn this around so I'm looking at the opposite face and create a sketch on this face here. I'm then going to project my geometry and then place points on each of the center points of each circle that we drew in our original sketch. I'm then going to go to our hole function, and Inventor automatically sees those center points and puts holes there. But we need to tell Inventor that we don't need to use all 3 holes or all 3 center points. I want to hold down my Shift key and unselect that middle. I then want to change what type of hole I'm putting in. It's a simple hole with no seat, and the diameter of this is 14. I'm then going to click on my plus sign here, and Inventor automatically sees that other center point. This hole is going to be 41.28. It's a standard regular hole with a diameter of 41.28 and say OK. Rotate this around so we're looking at it this way. We have one more hole to add, and that hole goes right here. But since this is a curved surface, we can't really put a sketch here. So we're going to have to click on the plus sign next to origin in our browser and then hover over our different planes. we want to choose our XZ plane. Make a sketch on that plane, right-click, and scroll down to Slice Graphics. This cuts it open as if we took a knife and just sliced it down that entire plane. So now we can see where exactly we want to put our hole. Instead of putting a hole, we're going to put a circle. So I'm going to put a circle that has a diameter of 6, and then I'm going to properly locate this. From the front of our part to the center of our circle, that is 13. Then I'm going to use my vertical constraint to line up the center point with my origin to make sure that it lines up right in the exact middle of my object. Go ahead and click on Finish Sketch and then Extrude. Inventor automatically sees our profile, and we want to cut it through all, but instead of going down, we want to go up and say OK. The last thing that we need to do before we are complete is add what are called fillets. And fillets just round off sharp corners. These fillets have a radius of 3, and then I'm just going to click everywhere a fillet needs to occur. One here, here, and then I'll rotate it around and click here. Once you have that, say OK, and you can now tell that this part has nice rounded edges that won't cut anyone in real life. Go ahead and save this. To place this on a sheet, we're just going to go back to our ENUS folder and then choose our title block. Once we're here, we can go ahead and place our view. It comes in at a 1/2 scale, but if we change it to a 1:1 scale, it'll fit nicely. We need our front view, our side view, and our top view. If we start dimensioning this, you'll notice that these dimensions are in inches, but according to our original PDF, everything is in the metric system, so we need to change this. So right-click and say OK to get out of the dimension command, and then right-click on the dimension and scroll down to edit dimension style. Units. When this dialog box pops up, you'll notice that we have many tabs as well as many pull-down menus. The one pull-down menu that we are most concerned with is the units and the linear pull-down. Change from inches to millimeters, and then change the precision from 2.12 to 0. All that means is that we will not have any decimal points. Save and close, and everything is now in the metric system. We then need to add our center marks. There are many holes and many circular features that need to have center lines, so we just click on those different holes. We also need to add centerline bisectors on our top view, as well as our side view. Oop. If your line doesn't go through the entire object, just grab that green dot and move it to the outside. It is now your responsibility to dimension both the index feed and the bearing. Make sure that you change the drawing names for each, save it, and then export it as a PDF. If you guys have any questions, please let me know, and I'll see you guys in the next video.